Hello my fellow gangsters. So we are going to do a drag and drop tutorial. We're just gonna make some simple objects to drag and drop, and then we'll do this cool little robot dude we're gonna use just for something a bit more interesting to drag around. So I've made a brand new project. When you installed Unity, make sure that you had also installed the standard assets. If you don't have them, you can get them from Unity's download page. But let's make a new project. I called it drag and drop, and let's go assets, import package, utility. And they already have a drag and drop thing. Import all that. They already have a drag and drop script that they've made. And once that's imported, let's also go assets, import package, prototyping, just for some objects to throw around, and import all of this. And I am going to go to my project window and create a folder called scenes, and let's just go file, save scene, go into the scenes folder. I'm just going to call it scene 01. So first let's give ourselves some area to drag things in. So let's go into the standard assets, prototyping, prefabs, and grab the floor prototype 64 by 1 by 64. Drag that into the scene at 0, 0, 0 for its position. And now for an object to drag, let's grab the cube prototype 2 by 2 by 2. And I'm going to move its Y position to about 3, and I'm going to click on its name and rename it to block. And I don't really like its material that much, so with it selected in the inspector window, I am going to the materials, and where it has navy grid, I'm going to click that little circle beside it and choose yellow grid, just so it stands out more. You don't have to do that. And so the way the script works, the built-in drag and drop script, it will drag anything that has a rigid body on it. So you want to add a rigid body to this guy. So you click add component, and you could type the word rigid body and just search for it to add it, or you can also go to physics rigid body. And I'm going to make the block a little bit heavy, so I'm going to change the mass to 2, so it's just heavier than default. And now let's create an empty game object to put our script on. So back in the hierarchy window, go create empty, and I'm just going to call this DragRigidbody. And if we go into the utility folder, there is a DragRigidbody script that we can drag on, or we can just click add component and start to search for DragRigidbody, and you can add it that way. That's a little bit easier. So now when we play the game, we can already drag it around and stuff because it's got a rigid body on it. Bam! Tutorial done, son! Just kidding. So also, when you drag this guy around, you notice he's getting like closer and farther away and stuff. So I want to make this a bit more 2D, and I also want to have the camera facing a certain direction, because later on we're going to have a script that's going to make a little robot guy always facing a certain direction. So with the camera selected, I'm going to move the camera's position to 0, 4, and 10, and its rotation Y to 180. And I'm also going to select the directional light and set its rotation Y to 180. And on our block, I'm going to go to its rigid body, and there's this constraints. Open that by clicking the little arrow and go check on freeze position Z so that it won't move around in the Z. So now when we play, it's a little bit more 2D-ish, so it won't get closer or farther away. It's pretty fun to throw around and stuff. And I'm just going to move this block's position X to -3, and let's create another object to drag around. So in the prototyping prefabs, I want to add the pickup prototype. So I'm going to drag that in, and I'm going to position it at 0, 4, 0. And for me, there's something wrong with Unity where the mesh renderer is actually missing. So you got this mesh filter here, and it's missing mesh. So it's called pickup prototype, so we can easily find the mesh. If you just click the little circle thing, it's obviously going to be called pickup prototype in here. And then again, we need to add that on the mesh collider. It's missing a mesh, so click the little circle thing, pickup prototype. Maybe it already worked for you, but on the version of Unity I'm using, it seemed to come in broken. I also really don't like this pink color, so I'm going to click on that one and make it yellow. And let's just rename this guy to coin. And just like before, we would go add component, let's get a rigid body, freeze position Z, and I'm going to also give this guy a physics material. So let's create a new folder called physics, and in there we'll create a physics material. I'm just going to call it bouncy, and for the bounciness I'll set that to 1, so that's like 100% bouncy. I'm also going to make the dynamic and static friction 0 so that it slides around, it doesn't really drag on the ground. And on our coin, on the mesh collider, it has a material right there, so you can drag bouncy onto there, or you can click the little circle thing and find bouncy. Another thing is you want to make sure that the mesh collider is convex, so check that to true. So now when we play, we should be able to toss that around, and see it bounces a little bit. It's lighter than the other guy, so if you throw it into it, you can tell like the box is heavier. So that's kind of cool, I guess. But now let's make something more interesting. So if we go to Window, Assets Store, and then search for Hibby Games, we have the Aaron's Assets, and we have added this little robot dude. This guy is from the Hibby Kart game that we're working on, but we decided to include him in this free asset, so you have a little character guy that you can use for your own games. So download and import this asset. So now in the Hibby Games folder, Aaron's Assets, Character Enemy Robot 1, Prefabs, there's a Character Enemy Robot 1. So I'm going to drag that in, and I'm going to name this Pet Robot, and position him at 3, 3, and 0. So now you got our cool little robot dude. So just like before, we're going to go add component, rigid body, freeze position Z. Let's give him that bouncy material. And we can drag him around just like everything else. Woo, look at me, I'm a robot. He should be more alive. So right now he just kind of like is just a dead object thing. So let's make it so that he will animate, and when we drag him, he will animate differently, like he's been flying around or something. And let's also make it so that he can sort of balance himself out and like stabilize so that he stays upright. So let's create a new folder called Animation, and inside that we will create an animator controller, I'm going to call it pet robot. And let's drag that onto our robot guy. Just underneath the add component button, you can just drag it on. And well, he's selected. If you go window animation, and he's selected, so we'll go create to create a new animation clip. Put that in the animation folder. Let's call this pet robot idle. And well, he's selected. If we click this little record button, now we're going to record his keyframes. So let's open him up, and let's go arm left, rotation Z of 50, and arm right, rotation Z of -50, eye left pupil, rotation Y of 50, the eye right pupil, that just has to stay at 0. So if I change it to something else and then change it back to 0, just to make sure that it has a keyframe. Control prop, so that's the propeller, rotation Y. I'm going to change it to something else and then change it back to 0, just to make sure we have a keyframe at 0. So let's move to 1 second in the timeline. So it's 60 frames per second, so frame 60 would be 1 second. And we'll go to eye left pupil, rotation Y of 0. And eye right pupil, rotation Y of -50. And arm left, rotation Z of 30. Arm right, rotation Z of -30. And let's move to 2 seconds in the timeline. So I can scroll back with my mouse wheel to see this better. And let's go to frame 120, 2 seconds. And go eye left pupil, rotation Y 50. Eye right pupil, rotation Y 0. The propeller prop, rotation Y, let's make that 360. So it's spinning. Arm left, rotation Z of 50. And arm right, rotation Z of -50. So now if I press play here, you can see that the propeller kind of like speeds up and slows down because it has like an easing in and out for the animation. It doesn't just go a consistent speed. So to change that, down here it has dope sheet because we're looking at the keyframes on the dope sheet. Let's go to curves, and if we select our inside our propeller the rotation Y, we will only see that curve. And you can see that the animation, it has this curve for how fast it's animating. So if we right click this keyframe, and I'm just going to go both tangents, it's the right tangent that we're changing, but I'm going to do both of them and click linear, then it goes straight. So we lose that curve. And then on the other keyframe, right click that, both tangents linear. So we really just want to change the left tangent, but it's easier to just do both. So now it's totally straight. So when we press play, this propeller animation just goes a solid, consistent speed. So that's pretty cool. And I'm going to stop recording. So now when we play the game, he will just be animating. He's looking around. But we want him to do a different animation when we drag him. Take that, robot. I'm gonna beat you to death with a giant coin. Bam! So if we have our pet robot selected again, and we're in the animation window again, right where it has the name pet robot idle, you can click on that and go create a new clip and put this in the animation folder. Let's call it pet robot drag. So this is what he'll do when we're dragging him. So with him selected, we click on the record again. So let's go to the left pupil, rotation Y 70, right pupil rotation Y minus 70. So now he's all cross-eyed. Arm left rotation Z minus 45. Arm right rotation Z 45. And let's move to half a second, so frame 30. And on the propeller, so control prop, let's set the rotation Y to minus 720. And I believe it will automatically make a keyframe at 0 for the first frame. Minus 720. And arm left rotation X 360. And arm right rotation X 360. So now he's kind of like, what? But let's make both of his arms and the propeller a consistent flat speed. So in the curves, on the propeller, so control prop rotation Y, we want to right click both tangents linear, right click both tangents linear. And on the arm left rotation X, right click both tangents linear, right click both tangents linear. And arm right rotation X, right click both tangents linear, right click both tangents linear. So now when we play, it's not stopping, they're just consistent. So we're done that one. So now you want to have the transitions between these animations. So if you go to Window Animator, and we have our pet robot selected, we have our default animation is the robot idle, and then this other one, the drag animation. So if you right click these, you can go set layer default state, but we want the default state to be the idle, obviously. And up here you got parameters. I believe you can also go Window Animator Parameter. I think that's the same thing. But anyways, right here, there's layers, then parameters. So we want parameters, and click the little plus, and a bool, which is a true or false. And we'll call that drag. So if dragging is true, then this will be on. If dragging is false, then it will be off. And so if we right click pet robot idle and go make transition, we have this thing. And if we left click on the robot drag, and then we select this transition, over in the inspector window here, we have a list of conditions. So click plus, and drag is true. So when drag is true, we're going to go to the drag animation from the idle. And this has exit time. I'm going to turn that off, so it doesn't have to wait till the animation finishes to start changing. And then right click on pet robot drag, make transition, left click on pet robot idle, now select that transition, and click the little plus, except we'll make this false. So when drag is false, then we'll go back to the idle. And let's turn off the exit time. So now if we were to, let's just play this. And now you can see he's doing his idle animation. You can see that that's what animation is playing up here. And if we turn drag to true, it will go to the other one. And if we turn drag to false, it'll go back up. So we just want to make so that when we grab this guy, we're going to set this to true. So one easy way to sort of check that is, if I have him selected in the inspector here, if we look at his rigid body, he has a drag parameter, totally different word, totally different drag, not dragging him around, but more like a friction when he gets moved around. But anyways, the DragRigidbody script changes his drag from 0 to 10 whenever we're dragging him. So one easy way to do this would be just to check whenever that changes to 10, then we can just we know that he's being dragged, and we can change it, drag to true in here, and change the animation. So let's make a script for that. So let's create a new folder called scripts, and create a new script, new C# script. Call that pet robot, I guess. And we can either drag that onto our robot. You have to wait for that spinny thing to finish. It's compiling the scripts. So we can either drag that down to the bottom here, or just click add component and start to search for pet robot and find it that way. So now we have our script on here, so double click that to open it up. And so what we're going to do is we're going to find, these are all components, right? Because we go add component. So we're going to check the rigid body component and see if this drag thing is set to 10. And if it is, then we're going to go into this animator component and set the drag parameter to true. So we will have a, let's just make them private rigid body, and call it our body, and a private animator, and just call that anim. And then inside of our start we will detect them, so we'll go our body equals get component rigid body. So that grabs it from here because our script is here and it's getting another component, and these are all components. And for the animator, exactly the same thing. Anim equals get component animator. And so in our update, we want to check if we are being dragged. So if our body dot drag, which is this guy right here, is equal to 10, then we must be dragging him around. So on the animators, anim dot set bool, which is this guy, the bool called drag, that word right there, we're setting that to true. Otherwise, else, this same thing, except we will set it to false. And save that. So now we go back, wait for it to compile. The little spinny thing in the bottom right has to finish. Then press play, and it should change these. Let me grab them. Woo! Now I'm flying, yo. Flying robot, son. But he's still kind of like retarded because he can't even stand upright. So now we just want to like stabilize him. So I will put a link below for this script, but I found on the wiki.unity3d.com there's a TorqueStabilizer. So you can just steal this. I didn't figure out how to make this or anything, I just took this part off of this website. So, but I'm just going to rewrite it anyway a bit. So back in our script, public float stability equals 3f, and a public float speed equals 15f. And since they're public, you'll be able to change them in the inspector if you want to balance them differently. And I'm going to put this code inside of a fixed update because it's dealing with physics. So void fixed update. And so stabilize upright. So vector 3 predicted up equals quaternion dot angle axis open bracket our body dot angular velocity, so how fast it's spinning, dot magnitude multiplied by math f dot radians to degrees multiplied by stability divided by speed divided by our speed variable, comma our body dot angular velocity, close that, multiplied by transform dot up. So that, I think, is the direction that it thinks up is. And then we have vector 3 torque vector equals vector 3 dot cross predicted up and vector 3 dot up. So I think that what it's doing is it's finding the direction that is in between what it thinks it wants up to be and what it up currently is. So if the character is sideways, then I believe vector 3 up is like the sideways direction that his head is facing, and predicted up is where he wants to be, and this cross is finding the direction in between those. So then we will go our body dot add torque vector multiplied by our speed that we can change if we want it to go faster. So if we wrote that correctly, he should now stabilize upright. So now if I toss him around, he's like, whoa, I can balance, but he's not facing the camera. He's just kind of spinning around. Bam, robot, eat this. So we want to make him always facing forwards to the camera too. So easy way to do that, there's probably a better way to do it, but I just copy this and duplicate it, and instead of up, do forward. So like stabilize forward. So predicted forward, this part transform dot forward, and this is why I had the camera facing a certain direction. Predicted forward vector 3 dot forward, and since torque vector already exists, we do not want to have it say vector 3 in front of it again, because we don't want to declare it twice. So now if we save that, it should make him face the camera, or face forwards anyway. So now when we drag him, he always kind of like straightens himself back out and looks the same direction. So it's pretty cool, flying around. Woo! You could also make him a prefab if we want. So if we create a new folder called prefabs, and all we do is drag him in there. Now we have like, can I drag in more pet robots? Pretty cool. Ooh, look at me, I'm a robot. Ooh. Bam, eat this robot. So now, another thing that we can do, just to make it more like a game, is in the standard assets utility, we have a smooth follow script. So let's go to our main camera, and let's put the smooth follow script on there, and put our robot on its target. So now when we play, the camera is going to follow him around, which is pretty sweet. Bam! Drag and drop, yo. Now we drag it and we drop it. pretty cool, so you could sort of start to make a little game with this. Fly him around, move some crap out of the way. Bam. Yeah. There you go, bam! Now we got ourselves a sweet little robot dude. Peace out, my fellow gangsters.